The tragic disintegration of China Airlines Flight 611. On May 25, 2002, a routine flight from Taipei to Hong Kong turned into a catastrophic disaster. China Airlines Flight 611, a Boeing 747-200, lifted off from Taiwan's capital with 225 passengers and crew on board. It was a well-traveled route known as the Golden Route, a short 90-minute journey across the Taiwan Strait. Passengers settled in for what was supposed to be an uneventful flight, unaware that they would soon become part of one of the most baffling aviation disasters in history. 20 minutes after takeoff, at an altitude of 35,000 feet, the plane suddenly vanished from radar. Air traffic controllers frantically tried to re-establish communication, but Flight 611 was gone. What followed was one of the largest rescue and recovery missions in Taiwan's history. The aircraft had broken apart mid-air, scattering debris across 325 square kilometers of the Taiwan Strait. But how could a modern jumbo jet simply disintegrate without warning? Was it sabotage, structural failure, or something more sinister? The mystery surrounding the sudden breakup of Flight 611 left investigators searching for answers in the wreckage below the sea. If you enjoy unraveling the secrets behind air disasters, make sure to subscribe for more in-depth investigations into aviation mysteries. The search for answers led investigators deep into the ocean, where hundreds of pieces of debris were painstakingly recovered and examined. Each piece held a clue, and with each discovery, the tragic story of Flight 611 began to take shape. Experts from Taiwan's Aviation Safety Council, ASC, the National Transportation Safety Board, NTSB, and Boeing joined forces to uncover the truth behind the disaster. Initial speculation ranged from terrorism to mechanical failure, but it wasn't until they recovered the 640th piece of wreckage that investigators found the smoking gun. A seemingly insignificant patch on the fuselage would reveal a critical design flaw and a missed opportunity that could have saved 225 lives. The investigation uncovered shocking details. A repair done 22 years earlier had failed to meet Boeing's stringent guidelines. Over time, hidden cracks had silently grown, weakening the aircraft's structure until the inevitable happened. Flight 611 had become a ticking time bomb, and the signs were there all along. This is the chilling story of how a routine repair job ultimately led to one of Taiwan's worst aviation disasters. Through meticulous investigation, a chain of errors spanning decades was finally exposed, leading to sweeping changes in aviation safety standards worldwide. As the aircraft soared past 35,000 feet, everything appeared normal. The experienced crew followed their checklists meticulously, and the autopilot was engaged to handle the steady cruise to their destination. Passengers settled into their seats, some gazing out of the windows at the endless blue sky, while others flipped through in-flight magazines or dozed off. Then, without warning, Flight 611 disappeared from radar. Taipei Area Control called out to the aircraft. There was no response. Panic set in among the air traffic controllers as they watched the blip representing the Boeing 747 suddenly split into multiple signals and scatter across the screen. An aircraft that had been cruising smoothly at altitude had inexplicably broken apart in midair. Authorities quickly launched one of the largest search and rescue operations in Taiwan's aviation history. Fishing boats, Coast Guard vessels, and military aircraft scoured the waters of the Taiwan Strait, hoping to find survivors. As the hours passed, it became clear that Flight 611 had met a catastrophic fate. Debris was scattered across a vast area, with pieces of the aircraft washing up on shore more than 100 kilometers away. The hopes of finding any survivors faded rapidly. Initial speculation ran wild. Could it have been a bomb? A mid-air collision? Sabotage? Or even a missile attack? Tensions between Taiwan and China were high at the time, and rumors swirled in the media. However, early analysis of the wreckage revealed no signs of an explosion or external attack. The mystery deepened as investigators from Taiwan's Aviation Safety Council and the U.S. National Transportation Safety Board began piecing together what happened. The Boeing 747-200, delivered in 1979, had a long service history but was considered a reliable workhorse of the skies.
When you see the 747 take off or land, it's almost transfixing because the plane itself is so beautifully designed.
Boeing called her the Superjet. The press called her Jumbo.
Yet, something had gone catastrophically wrong, and uncovering the truth would prove to be a painstaking process. What could have caused a seasoned aircraft, operated by experienced crew members, to disintegrate mid-flight without warning? The answer lay hidden within the recovered wreckage, 639 pieces pulled from the sea, each holding a potential clue. The race to solve the mystery of Flight 611 had begun. The race to solve the mystery of Flight 611 had begun. As search crews worked tirelessly to recover debris, investigators from Taiwan's Aviation Safety Council, ASC, and the U.S. National Transportation Safety Board, NTSB, arrived on site. With the discovery of 639 pieces of wreckage, speculation ran rampant. Was it a mechanical failure, sabotage, or something more sinister? The media quickly latched onto theories, with some suggesting the possibility of terrorism or even a missile strike. Relations between China and Taiwan had long been tense, and with military exercises occurring in the region at the time, the idea of an attack couldn't be ruled out. However, investigators found no evidence of missile impact or explosive residue on the recovered wreckage, dismissing the theory of foul play. The search for the aircraft's black boxes became the top priority. After weeks of effort, the flight data recorder, FDR, and cockpit voice recorder, CVR, were finally recovered from the ocean floor. The hope was that these devices would shed light on what transpired in the final moments of Flight 611. Analysis of the CVR revealed that the cockpit was operating normally until the moment of the disaster. The pilots were calm, following standard procedures, and no signs of distress were detected. Then, abruptly, the recording was cut off, evidence of a sudden and catastrophic event. Meanwhile, investigators examined radar data that showed the aircraft breaking apart in mid-air. The radar recorded multiple fragments falling separately, indicating that the breakup had occurred at high altitude and at cruising speed. But why? Attention soon turned to the recovered debris. A breakthrough came when a specific piece of fuselage, designated as Item 640, was retrieved. This section of the aircraft, which included the rear cargo door, displayed unusual characteristics. Close examination revealed telltale signs of metal fatigue, a potential clue that structural failure might have been a contributing factor. The hunt for answers was far from over, but investigators now had a crucial lead. Was there a hidden flaw in the aircraft's structure, one that had gone undetected for years? After weeks of relentless searching, the black boxes were finally located on the seabed.
Some areas of the bottom here are almost 3 miles down. Searchers will be listening for the automated ping that the boxes give off, and that pinging is only designed to continue for about a month.
Investigators eagerly retrieved the devices, hoping they would provide definitive answers. The cockpit voice recorder, however, yielded little useful information. There were no warning sounds, no alarms, and no panicked shouts from the crew. Just the routine chatter of a normal flight until the very end, when the recording abruptly stopped. The flight data recorder offered some insights. It indicated that Flight 611 had been operating normally until the aircraft suddenly lost altitude and structural integrity in a matter of seconds. The data suggested an in-flight breakup rather than a loss of control by the pilots. While the black boxes didn't provide a smoking gun, forensic analysis of the recovered wreckage did. Investigators closely examined a large piece of the fuselage, designated Item 640, which revealed a shocking discovery: evidence of metal fatigue. The section, located near the rear of the aircraft, showed signs of a long-standing crack that had grown over time, weakening the structure until it could no longer withstand the internal cabin pressure. Adding to the intrigue, investigators found that the damaged section had been repaired 22 years earlier, following a tail strike incident in Hong Kong. During landing, the tail of the aircraft had scraped the runway, causing minor damage.
According to the Hong Kong authorities, more than 120 people were injured, 5 of them critically. When the injured arrived at a pier, they were taken to waiting ambulances and then to hospital for treatment.
Instead of fully replacing the damaged section as recommended by Boeing, China Airlines had applied a temporary patch, a doubler plate, over the damaged area. Over the years, the patched section had developed cracks, which had gone unnoticed during routine inspections. This shocking revelation raised questions about maintenance practices and oversight. The improper repair, combined with years of pressurization and depressurization cycles, had led to catastrophic structural failure. As the investigation unfolded, it became clear that the tragedy of Flight 611 was not caused by sabotage, weather, or pilot error, but by a decades-old oversight that had finally caught up with the aircraft. As investigators continued their painstaking work, attention turned to a crucial piece of wreckage recovered from the sea item number 640. Unlike other debris, this large section of the aircraft's fuselage displayed unusual characteristics. It had a metal repair patch, known as a doubler plate, attached to its surface. This discovery raised immediate concerns. Upon closer inspection, investigators found telltale signs of long-term damage. The fractured edges of the metal did not show the jagged, torn appearance typical of a sudden break. Instead, they exhibited smooth. The fractured edges of the metal did not show the jagged, torn appearance typical of a sudden break. Instead, they exhibited smooth, flat surfaces indicative of metal fatigue, small cracks that develop and grow over time due to repeated stress cycles. This evidence suggested that the failure was not a sudden event, but rather a problem that had been developing for years. Digging deeper, the investigation team scoured maintenance records and discovered that the doubler plate had been installed 22 years earlier, following a tail strike incident during landing. In 1980, the same aircraft had suffered a tail strike while landing in Hong Kong, scraping its rear fuselage against the runway. The repair, intended to be temporary, had been improperly completed. Instead of following Boeing's recommended procedure of cutting out the damaged section and replacing it with new material, airline maintenance crews had simply sanded down the damaged area and covered it with the doubler plate. This improper repair had effectively hidden the damage from future inspections. Over the next 2 decades, as the aircraft went through thousands of pressurization cycles, the concealed cracks beneath the doubler plate continued to grow. Each time the plane climbed to cruising altitude, cabin pressure would expand the weakened area, worsening the fatigue. The investigators realized that Flight 611 had been a ticking time bomb. The cracks had finally reached a critical length, leading to catastrophic structural failure during its final ascent. The aircraft's tail section broke away, triggering a rapid decompression that tore the plane apart mid-air. This revelation shocked the aviation community. It highlighted the dangers of improperly executed repairs and the critical importance of thorough inspections, particularly on aging aircraft. Despite modern maintenance practices, the failure to follow correct procedures decades earlier had tragic consequences. With the cause of the accident now clear, the investigation shifted focus to ensuring that such a failure could never happen again. Over the years, the aircraft endured the relentless cycle of pressurization and depressurization, which gradually weakened the already compromised section of the fuselage. Each takeoff and landing caused the hidden crack beneath the doubler to expand ever so slightly, until it reached a critical length. On that fateful day in 2002, as Flight 611 climbed to cruising altitude, the internal pressure proved too much for the weakened structure to handle. The fuselage ruptured, triggering a catastrophic mid-air breakup. Investigators were stunned by how close the airline had come to catching the fatal flaw. Just a year before the accident, China Airlines had begun a major inspection program for aging aircraft, which included reviewing previous repairs. Photographs taken of the doubler plate during routine maintenance even showed signs of discoloration, evidence of air and moisture slowly leaking through the crack underneath. However, the warning signs were overlooked, and the plane was allowed to continue flying. The realization that a 2-decade-old maintenance error had been quietly lurking beneath the surface shook the aviation industry to its core. It highlighted the dangers of aging aircraft and the critical importance of thorough inspections, not just of visible components, but of past repairs that could hide life-threatening flaws. With the cause of the accident now clear, attention shifted to the broader implications for aviation safety. Regulators and airlines worldwide faced urgent questions. How many other aircraft could be harboring similar hidden dangers? And what steps could be taken to prevent another tragedy like Flight 611? The tragic loss of China Airlines. Flight 611 served as a sobering reminder of the hidden dangers lurking in aging aircraft and the consequences of improper maintenance. The investigation ultimately revealed that a 22-year-old tail strike repair, improperly carried out and inadequately documented, had been the ticking time bomb that led to the catastrophic in-flight breakup. For 2 decades, the aircraft had undergone thousands of pressurization cycles, each one slowly expanding an unseen crack beneath the doubler plate. It was only a matter of time before the structural integrity of the fuselage gave way. When it finally did, it resulted in a catastrophic failure that cost the lives of all 225 passengers and crew on board. In response to the findings, aviation regulators worldwide took immediate action to prevent similar tragedies. Airlines were required to conduct thorough inspections of previous repairs, with a focus on aging aircraft and structural integrity. Non-destructive testing methods, such as ultrasound and eddy current testing, became standard procedures to detect hidden cracks beneath doubler plates and other critical repairs. Additionally, maintenance documentation requirements were tightened, ensuring that future repair work adhered strictly to manufacturer guidelines and regulatory oversight. Airlines were also urged to adopt proactive inspection schedules for aging aircraft, rather than relying on routine checks that could miss underlying issues. The crash of Flight 611 also underscored the importance of transparency and accountability in aviation safety. It highlighted how critical it is for maintenance crews, airlines, and regulatory authorities to work in tandem to uphold the highest standards of safety, ensuring that every aircraft in the sky meets rigorous airworthiness criteria. Though the tragedy of Flight 611 will always be remembered with sorrow, its legacy has contributed to safer skies. The lessons learned have helped shape modern aviation protocols, ensuring that past mistakes are not repeated and that passenger safety remains the top priority. In the end, the story of China Airlines Flight 611 serves as a powerful reminder that in aviation, even the smallest oversight can have devastating consequences. Continuous vigilance, rigorous maintenance, and an unwavering commitment to safety are the keys to preventing such disasters in the future.